we're going to get started with day 2, 8.2, which is problem solving with proportions. Okay, so again, remember that proportions, we're going to be setting up ratios that are equal to another ratio. Okay, proportion definitely is an equation with an equal sign. So yesterday we looked at the cross product. Okay, when we did A times D will be equal to C times B. And then we also looked at the reciprocal property where we flipped. So we had B over A equals D over C. So there are 2 more properties that we're going to be looking at regarding proportions. Here, kind of as you may have seen yesterday in some of the examples, when we were working out some of those problems, the application problems, I was trying to mention to you guys that it depends how you set it up. Some of you are going to set up problems differently. So if you look at this property, if we have A over B, we're comparing A and B, and that's equal to C over D, you can also write it as if you were taking this information on top, okay, and then you have the information below, and then you replace it with comparing the information on top equal to the information below. Okay, so there are many different ways that we can write proportions, but you have got to keep either all of the information regarding the same idea as the numerator on the top or on the same side. Okay, and then the other property over here, we have A over B equals C over D. Then A plus B over B equals C plus D over D. Because if we were to separate this, we would still end up with this information. Okay, because we'd have B over B, which is 1, D over D, which is 1. Okay, so let's look at some examples. Tell whether this statement is true. So if we have V over 5 equal to W over 9, then V plus 5 over, V plus 5 over 5 equals W plus 5 over 9. Okay, is this true or false? Well, I'm hoping that most of you are going to say false. Okay. It would have to be rewritten as V plus 5 over 5 would be equal to W plus 9 all over 9. Okay, so in this case, this is incorrect. All right, so moving on to example number 2. Now we're going to actually be looking at a picture of the proportion. So we have the diagram. We have HJ and JL. I'm going to change that color. Okay, and then that's equal to GK. So then we have GK. And that's over KL. So we're kind of looking at these pieces here. So we want to figure out what GK is. So I'm going to use this proportion that they're giving me, and I'm actually going to plug in all the specific points now, or all the values. So HG is 6, and JL is 12. And then GK is going to be X, and KL is 10. So now I need to solve for X. I want to figure out what GK is, which is also noted as X. So I am going to cross multiply. Okay, 12 times X is going to be equal to 6 times 10. Okay, so then I have 12X equals 60. And divide by 12 on both sides. So X equals 5. Okay, and X is GK, so we are answering the question. GK is 5. All right, so we're going to go down now to geometric mean. So the geometric mean of 2 positive numbers, A and B, is the positive number X. So anytime you have 2 numbers, you're going to kind of set up the information like this. And if we were to cross multiply, we would have A times B equals, and then X times X, which is also AB equals X squared. Because again, when we multiply, we add the 2 exponents. And then in order to actually figure out what X is all alone, we need to get rid of this root, so we're going to square root it, or I'm sorry, get rid of the square, so we're going to square root it. And anything we do to one side, we got to do to the other. So then we are ended up with x equals the square root of AB. Okay, so the geometric mean, sometimes you'll be able to set up a proportion, and then sometimes, or you can always set up a proportion, and then you can always figure this out. Okay, so find the geometric mean between 8 and 18. So if you want to set it up as a proportion, you could say I have 8 over x, and I don't know what x is, over 18. Or just jump right to this too. So x would be the square root of 8 times 18, which is going to be 144. Okay, when you take the square root of 144, you'll get that x equals 12. Anytime you take a square root, it's plus or minus, but in this case, it's only going to be the positive. All right, so let's look at an actual problem and set it up. So the two buildings shown have the same width to length ratio. The distance labeled x is the geometric mean of 105 and 210. So find the value. So again, looking at our proportion, we have 105 compared to x. So 105 over x will be equal to, we'll keep our units, and then we have x and 210. Those are our side values. Okay, so I started off though with the information of the smaller building, so that's going to stay on top. So I'm going to place x and then 210. Okay, so again, if you set up a proportion a little bit different, that's fine, but you always want to keep the same on top and the same on the bottom. All right, so now from here we can do cross multiplication and come up with that x is going to be the square root of our 105 times 210. So we'll have x squared equals 105 times 210 is going to be 22,050. And then we want to take the square root. So x is going to equal roughly, actually let me put an about. It's about, because I'm going to round it, 148.5 meters. All right, I am going to make one more video for the next page, okay? So.